Okay, we'll look at two further examples that will be related to equating, but they're going to be related in a slightly different sense by the fact that something is going to be a factor of something else, and then they're asking you to find some sort of unknowns, or in this case a third factor. So when I get an expression like this for the first one, it says this large expression is a factor of this. We know that that means I can divide it into it equally. So I can go 2x squared plus bx minus 5 can divide fully into this large expression here. So I write it out and I begin my division. I need 2x cubed and I start off with 2x, so I should times everything by x. So meaning I will end up with 2x cubed. Now it's x times bx, so that's bx squared. And then it's minus 5 times x, so minus 5x. Again, I see, is there any sort of remainder? So I flip it, so minus, minus, plus. This will cancel the x cubes, and now something has to happen here. Minus x squared minus bx. Now the difficulty with that is I'm not really sure what happens, because I don't know what b is. I don't know how to really take it away from a minus 1 to get it down to one constant. So the best I can really do in an instance like this is say, well, it is factorizing it, but the way we're going to factorize it is we're going to open up a set of brackets. This is going to be the x squared expression, and the best I can do is, well, it's minus b, and a minus x is minus 1, so that's the expression I'm going to end up with. Now you can write it in a lot of different ways. That's just one way to do it. And something similar is going to happen here, because I have a k plus a 5. I don't really know how to do that. So the best I will do is say it's k plus 5, and that's giving me the x. Okay. Again, what's happened here is you factorized out an x, but in a simple sense, that's all we're doing, is putting everything into little brackets. From there, we'll bring down the last term to join in, which is the positive 10, and then we begin the division again, or continue on the process. So I need this to appear, and I have a 2x squared. So how could I possibly make that appear? The difficulty with something like this is I really, again, don't know what happens. But I have to use my intuition. Something up here is going to multiply with this, and it's going to make that expression appear. So if there is a number in front, it's going to be something that'll be times by a 2 that ends up with this expression. So this expression is going to be involved. But if I go that times that, it gives me 2 times that expression, which is obviously just too much. I need the 2 to cancel out. The way to cancel the 2 out is if it was a over 2 or a fraction of a 2. So that will make this expression appear. So that is what I'm multiplying by everything here. Now it doesn't seem a great choice. It seems quite difficult, but it will work its way out in the end. So that means it'll be this expression times bx next. So it's going to be b times that expression. That will give me the x. And then it will be that expression again times the minus 5. So minus 5 times this expression. Again, not great luck. They don't seem to do much or make life simple, but they are going to work its way out. From there, I see, well, is there remainders? So I have minus, minus, plus. This cancels. What has to happen here? If it is a factor, which they've said it is, this also has to cancel down to a 0. So this is another 0. And then this here has to do the same thing. If it is a factor, this has to cancel down to 0 at the very end, because we are at the end of the sum. So we end up with this. Now, this is where the equating comes into it. These two things must equate to make a 0 of sorts. So I will write them out and let them do it. So the k plus 5 minus the b times that expression over 2 will end up being 0 in some sort of sense. And the same thing is going to happen here. So again, let's put it over this side. 10 plus 5 times that expression will end up as 0 again in its own sense. So from there you have two things that don't particularly look nice or easy to deal with, but they are going to end up giving me my letters from it. So if I just take this one to start me off and see how far I can get. This will be 10 minus 5b minus 5 over 2 equals 0, doubling everything to kill the fraction. So it's 20 minus 5b minus 5 equals 0. So from there it's 15 minus 5b equals 0. So that's 15 is equal to 5b. b would then be 3. So I actually have found b from that. Again, not a great expression to work with, but it has allowed me to find b. When I go to the second expression, I know what b is. So it's k plus 5 minus b is 3. So 3 times minus 3 minus 1 over 2. That whole thing can go to the calculator if you feel it needs to. So that's k plus 5. And if I go to the calculator, that entire expression comes back as a positive 6. So that would be k plus 11 equals 0. So k is equal to minus 11. So I now have the k and I have the b. They do ask for the other factor. The other factor is from the solution up here. So I go to it. So it's x. And then it's minus b minus 1 over 2. I know b is 3. So that's minus 3 minus 1 over 2. So once that's calculated, that's going to come back as minus 2. So there's the third factor as well. Now, not a great question, but it's quite difficult in the way we approach it as well. And even the one of the solution or one of the division parts up there was a fraction. But if it's something that doesn't seem to match, that may be what happens. So that's one example. The second example will follow a similar enough type of process. So if we look at that one, it says that this large quadratic expression is a factor of this expression here. And then they want to find something to do with b and d afterwards. So we'll approach in the same way. If it's a factor, it divides in. So x squared minus ax plus b can divide fully into that large expression. So it's x cubed. Now I've noticed there's no x squared component, so I'm going to put in a 0x squared plus cx plus d. So starting off the division, how can that happen? If I'm starting here, okay, it must be x. So everything's times by x. So x cubed minus ax squared plus bx. See if there is any sort of remainders. Minus, plus, minus. Cancelled. 0x squared plus ax squared. Well, that's actually quite simple. It's just ax squared. So the 0 has nothing to do with it. Then I come here. It's cx minus a bx. I don't know how that's going to work to give me one thing. So we do a similar enough thing. Like the last question, it'll be c minus b. That will be the x. And again, that is factorised. I'm factorising the x out of it. Next, we bring down the d component and we continue. So I need an ax squared and I'm starting with an x squared. So if I times everything by a positive a, that should do it for me. So it's an ax squared minus ax times a, so minus a squared x. And then it is b times a, so it's ab or ba. So from there, we see if there are any remainders. I am at the end of this division now, so there should be no remainders, and it does say it's a factor. So that will cancel to 0. This should cancel down to a 0 as well if it's a factor, and the similar enough thing should happen here. The difficulty is I don't really know if it does, or how could it? We don't have an inclination that it does. So this is where the equating comes into it. This expression should become a 0. So c minus b plus an a squared must end up as 0 in some sort of sense. And a similar enough thing here, d minus an ab must also become a 0. So from here we can use it to find the solutions they want. They want to isolate B in terms of A and C. So this expression has all the A's, the B's and the C's. So to isolate B would be, just bring it over the far side. So it'd be C plus an A squared equals positive B. I just really brought him over. And that's reading exactly what they want. B is a C plus an A squared, which it is. So I have that completed. If I go to the second one, they want to isolate D. So to isolate D, here we'd have D is equal to AB. Now it doesn't look like what they want because we have A's and B's and they have A's and C's. So I should be able to remove that B in some sort of way. And I have an expression that is A's and C's that removes the B out of it for me. So D, if I just bring it over here, D is going to be A times B, which I am saying is this expression, C plus A squared. So that is D is equal to AC plus A cubed. Is that what they have? An A cubed and an AC, yes, there we go. We have the expression represented in the form they want. So when it comes to slightly larger equating type things, if something is a factor, it divides in fully, meaning when you get to the end of your division, things should be able to be represented as equal to 0, and from there you can isolate specific things as you wish.